Good evening, everyone. Welcome you all on this platform. That is One Mark Solution, and as you know that we are conducting webinars on the different subject, different chapters with the only specialized with the 1 mark questions like multiple choice questions, fill-ups questions, true false, assertion region questions, one word answer questions, match the column questions, etc. So today we are going to discuss about chapter 11 of class 12th physics, and the name of the chapter is dual nature of radiation and matters. So today, dual nature of radiation and matters we will discuss with the subject expert, and already, as you know, that different subject experts are coming on this platform and discussing the different topics, different chapters of different subjects from class 6 to class 12. So I would like to introduce you today's subject expert, Madam Sanitha MM. Madam Sanitha MM, I welcome you on behalf of One Mark Solution as well as on behalf of all the viewers on
Thank
this
you, sir.
platform. Madam Sanitha already have taken chapter 14, also semiconductor. And today madam is going to take dual nature of radiation and matters. Madam is working as HOD science and PGT physics in IVS International School, Thrissur, Kerala. uh, we are very lucky to have you, ma'am, that
Thank you,
already
sir.
you have taken the chapter 1, chapter 14. It's very good, and so many students have watched that video, and
Thank you.
they have been benefited. So definitely from today's session also they will be benefited, the students who will join us, who will join this session. And later on after session, this video will be available on YouTube, so they can watch this video through YouTube channel One Mark Solution. Those who are new on this channel, I would like to request them to subscribe the channel and press the bell icon, so that upcoming webinars, they get the information about the upcoming webinars. Now I will not take much time. I would like to hand over Madam Sanitha. Madam, please.
Thank you, sir. And thank you, One Mark Solution team, for giving an opportunity again to discuss one marks based on all the topics, that means all the concept in the dual nature of radiation and matter. That is chapter 11. Good evening once again. Good evening, children, especially children. Please note one more important point, that is, you should know the concept very well, first of all. Then only you can do any questions based upon that. If it is a assertion and reason, or the new thing which is added by CBSE, assertion and reason, and the case based, that means a paragraph will be there or case will be there. Based upon that, some questions will be asked. That also you can do it. And usual MCQ questions will be there. If it is 2 or 3 marks, the concept you have to make it clear. Now, within no time, I'm going to discuss about the questions based on dual nature of radiation and matter. So dual nature, what do you mean by dual nature? Means two nature will be there. Two nature means here we are going to discuss the particle nature and the wave nature. That is dual nature. That is 11th chapter, NCRT, second text, we can say third chapter is that one. Now, we will go into the deep about this chapter. You can see that together the Max Planck and the great scientist Albert Einstein explained the main phenomenon, photoelectric effect, by assuming that light was actually a stream of little particles or packets of energy known as photons or quanta. That means the packets of energy, we'll call it as photons, as well as we can say quanta, and the equation for that is equal to nu. That is very, very important thing. Now, according to de Broglie, actually it is written de Broglie, G is there, but it's pronounced as de Broglie. Concept of matter waves. What is matter waves means? We can say that the moving particles, when it is moving particles, we can say waves associated with moving particles, we can call it as matter waves or de Broglie waves, we are calling it as. The matter has dual nature. It means when the matter is moving, it shows the wave nature, like interference, diffraction, all these things you are studying in wave optics also. Now let us start with our questions. The first one, we are going for one word answer. How many electron volts make up 1 joule? Why we are giving this question is electron volt is the unit of energy we are using in atomic and nuclear physics. So let us start with 1 electron volt. What is 1 electron volt? 1 electron volt is equal to 1.6 into 602 is there. 6, if you can, when you are doing the calculation, you can take it as 6 into 10 raised to minus 19 joule. So what is 1 joule? 1 joule, we can say, we can take the reciprocal of 1.602 into 10 raised to minus 19. You will get the answer 6.02 into 10 raised to 18. So 1 joule is equal to this much electron volt will be there. Now, what is 1 electron volt? If the question is asking how many electron volts make up 1 joule, only you have to write the answer, the 6.02 into 10 raised to 18. Only that much you have to. Now, I'm just giving the description for 1 electron volt. What is 1 electron volt? All should know that. 1 electron volt is the energy gained by an electron when it is accelerated. That means when we are giving some potential difference of 1 volt. So this unit of energy, I'm again repeating, this unit of energy, that is electron volt, is commonly used in atomic and nuclear physics. So we are dealing with that chapter. Now we'll go for the second part of the question, that is one sentence answer. What do you mean by intensity of radiation? If you want to go for deep into the chapter or the photoelectric emission or emission of the electrons, you should know what do you mean by intensity. When the light is incident on a surface, you should know how much intensity will be there. You should know the strength of the radiation. What is that actually? We can say intensity means strength. Strength means what is here. We can say the number of photons per unit time, per unit area. That is very, very important. That is the number of photons. Photons means energy, only packets of energy, per unit area, per unit time. And its SI system is watts per square meter. That means actually number of photons, we can say joule per second per meter squared. So joule per second, we can call it as watt and meter squared. So that is why watt per square meter. Usually the students will make the mistake of this unit, that is the intensity of radiation. So that you have to note it. Next, we can go for the next question. That is also one sentence answer. Yes, why is photoelectric emission not possible at all frequencies? So what is emission? What do you mean by emission means? We can say the electrons will be emitted. Why electrons we have to emit? Why? Because you know that in atom, electrons and protons are bound to the nucleus. That means that protons and electrons will have an electrostatic force of attraction. That means electrons are bound to the nucleus. If you want to take away the electron, that means if we are calling electron, please come, it won't come out. We have to give energy to overcome this force of attraction. Then only it will come. So if you want to give some energy, we can give in form of light or electric field or even heat also. So it will come out. Here we can say photo. Photo means something related to light. So here we are giving light and the electrons are emitted from it. We will call it as photoelectric emission. Why it is photoelectric emission? Not possible at all frequencies. Frequencies related to energy, we can say that E is equal to H nu is the equation. When nu increases, then only the energy also increases. Why? Because H is a Planck's constant. All of you know that. And H nu, H will remains constant and nu is only the changing. So when nu changes, that means the frequency changes, the energy also will be changing. So all the frequencies, we won't get the electrons coming out. Why? Because minimum energy should be there. That minimum energy, we can call it as threshold energy or we can call it as work function. You can see in a picture, just you can imagine that one metal surface is there. You can see that some electrons are there inside, an atom, and nucleus is also there, right? So when you're giving some light, what is happening? Energy. Yes, if you are giving some energy, what is happening? Light means what is it? Energy only. The electrons will be ejected and you can see that electron not only ejected, it will move with some velocity, with some kinetic energy. Why? Because of this energy only. Now we can go for next question. Consider the figure given below. You can see a figure there. For photoelectric emission again, how will you reconcile the momentum conservation? Note that we have to note that one point is there. The light have momentum. That means photon also have momentum in a different direction than the emitted electrons. You can see in the picture, light is incident on a metal and electrons are ejected there. Here, what is happening? It is 1 mark, one sentence only. Only have to say the answer one sentence. The sentence you have to write it. The momentum of incident photon is transferred to the metal during the photoelectric emission. That means during this emission, during this process, they are transferring. Only this much you have to say. But in detail, you should know that what is happening there. In microscopic level, why we are focusing the microscope? You know that atoms and nucleus is very small, right? So atoms absorb the photon and its momentum is transferred mainly to the nucleus and electrons. So the electrons they are getting, they will be excited out of the surface. Now we'll go for the next question. We can see, so one word answer. What is the relation between de Broglie wavelength and temperature? There is a relation between the wavelength and temperature, de Broglie wavelength and temperature. We can say lambda is equal to h by root of 2 mkt. Actually, the equation is lambda is equal to h by mv. Lambda is equal to h into root of 2 m energy. Energy is related to temperature. You know that average kinetic energy is related. And k here, k is the Boltzmann constant, and T, of course, you know that's absolute temperature. Now let us move to the next question. That is again one word answer. It's very, very important one. What is the mass of a photon of frequency nu? Usually the children will have a doubt. Why? Is the photon is having some mass? Sure, energy and momentum, they know it, but they should have some doubt. What is there any mass there? So that is why we are included this question actually. E is equal to mc squared, the famous Einstein's relation, mass energy relation. And of course, you know that E is equal to h nu. We can put it together. Mc squared is equal to h nu. So what is m from this equation? H nu divided by c squared. So sure, the photon is having mass. Now we can go for the multiple choice question. The minimum energy required to eject an electron from metal surface. Minimum, if you are using the word minimum, we can use threshold energy here. But in this choice, you can see that no threshold is there. But you can see the work function. So the minimum energy, we can say that we can call it as work function. You are studying in the first chapter also, electric charges and fields. What is work function? So what is work function? It is a minimum energy to give the electron to eject from the metal surface. We have to pull it out. So the answer is the first one, that is work function. Next, we can go for the second question, that is match the following. Here you can see two columns are there, right? So first column, we can say the emission process are there. Light, if light is giving as the threshold energy, we can call it as photoelectric emission. If electric field is giving, we can call it as field emission. If heat means thermal energy. If we are giving that, we can call it as thermionic emission. Now we can just match it. It's very simple. You can match it. The first one, phenomenon of emission of electrons to the metal surface on heating. So thermionic emission, A and R, we can match it. And the second one, the phenomenon of emission of electrons from the metal surface by illuminating it with suitable frequency of light, that is photoelectric emission. And the third one, the phenomenon of emission of electrons by applying a very strong electric field, that we can call it as field emission. So you can see that options also, you should be very careful that options you have to match it. So the option you can see AR, BP and CQ, that is the C, option C. Now, multiple choice questions, we can see that the work function of photoelectric material is 3.3 electron volt. The threshold frequency will be equal to, so many choices are there. You can do it very simply. You can do it. E is equal to h nu is the equation for the photon. You know that. But here we have, it is asked the threshold frequency. So nu we can find it from E is equal to h nu. So what is nu? Nu is equal to E by h. So by calculating, you will get the answer 8 into 10 raised to 14 hertz. But you should be very careful that 3.3 electron volt is given. So you have to convert into joule. 1 electron volt is equal to 1.6 into 10 raised to minus 19. We have already discussed it. You have to multiply 3.3 into 10, 1.6 into 10 raised to minus 19. After that, you have to divide by the H. Then you will get the answer in hertz. That is 8 into 10 raised to 14 hertz. The option is A. Next, we can go for again the multiple choice question only. The stopping potential V0 for photoelectric emission from a metal surface is plotted along y-axis and the frequency of incident light along the x-axis. That means the frequency and the stopping potential, we are drawing a graph, and this graph is very, very important. And the question is a straight line. You can see the graph also here, the frequency and the stopping potential. 4 graph is very, very important in this chapter. That is one of the very important graph is this one. So you can see that a straight line is obtained as shown. Planck's constant, how will you get the Planck constant from this? Our Einstein, great Einstein, have discussed that how we will get the Planck's constant in this graph. Planck's constant, we can say we will take the slope first of all. Slope will be h by e. From the Einstein's equation, we will get h by e. What is h now? That is the Planck's constant. So we can multiply the slope by the charge of electron. You will get the Planck's constant that we will deal in the next question. So the answer is B. Next, we can go for the same graph, but different manner the question asks. This is also a board question. That's a very important question. You can see when a given photosensitive material is radiated with the light of frequency nu and the maximum speed of the emitted photoelectrons. Photoelectrons means what is it? The electrons which is emitted using the light. That is why we will call it as photoelectrons. And the surface we can call it as photosensitive surface. And the current we are obtaining is photoelectric current. Everything we are adding photo. The square of V max is observed to vary with nu as per the graph is shown in the figure. In the previous graph, we have drawn nu and the stopping potential. But here you can see the V max squared and the frequency. How will you get the what is it? Planck's constant. How will you get the expression for the Planck's constant? We will see that. Usually the question arises for 2 marks. They will ask for 2 marks. If it is 2 marks, one more question will be there. That means you have to find the y-intercept also here, or work function we can say. Here it is not asked, only 1 mark question. So we are limited to Planck's constant. You can see the equation. Kinetic energy is equal to half mv squared is equal to h nu by h nu 0, that is phi 0, or you can write h nu 0, or you can write w also for the work function. Now this equation we can call it as photoelectric equation, Einstein's photoelectric equation. How it comes actually? You can take a metal surface. In the metal surface, one light will be incident. A part of the energy is used for ejecting, and a part of energy is used for kinetic energy. That means moving. So we can say h nu is equal to, that is energy incident, is equal to h nu 0 plus half mv squared. So the equation becomes half mv squared is equal to h nu minus phi 0. Phi 0 can be written as w also. Now we can say from this equation you will get V max squared is equal to, that means m and 2 we can take to the right side. So the equation becomes, you can say that V max squared is equal to 2h by m into nu minus 2 phi 0 by m. You can see that equation, it's a straight line. So y is equal to mx plus c. That is the equation for the straight line. You compare this equation. So what is m you are getting here? 2h by m. That is slope. Slope is equal to 2h by m. From this slope, you will get the Planck's constant. You can see 2h by m is equal to, what is the slope of the graph given here? We can say L by n. So the equation becomes h is equal to, we can say, what is it? The equation will be the option ml divided by 2n. That is option B. That is the answer. This is very important question. All of you have to note this one. Next, we can go for the next question. It's very simple. Kinetic energy of emitted electrons depends on. Energy depends on, sure, energy will be depending on the frequency only. So kinetic energy depends on emitted electrons. Anything we can say, it depends only the frequency. So what is the answer? We will get it very simply. We will get it. What is the answer is A. That is the frequency only. Intensity, it does not depend. It depends on the number of photons, and nature of atmosphere doesn't depend, and none of this. So the answer, correct option is frequency. Now let us move for the next question. The graph shows, again the graph is there, shows the variation of photoelectric current versus applied voltage for the 2 different photosensitive materials for 2 different intensities. You can see 2 different intensities of the incident radiation. Identify the pairs of curves that corresponds to different materials but same intensity. You can see same intensity means intensity is same. We can say that, yes, you can say 3 and 4. It is written like that. It is having same intensity. And see the stopping potential. Stopping potential, it is, what is it, meeting at that point in the retarding potential, we can say. And these two, actually these 2 graphs are incorporated in this graph. 2 graph means how the intensity depends on the stopping potential. Stopping potential does not depends on the intensity. But the stopping potential depends only on the frequency. That also you can say. But here we are using two materials. So how will you identify the same intensity? From it's very clear, you can see that. Just see the option and see the graph, you will get the answer for it. See, 1 and 3 is having same intensity, so we can take that pair. The other one we can say 2 and 4 with the same intensity. Intensity, you can see that, isn't it? It will be saturated. If intensity increases, current also increases. After some time, it will be saturated. That is why a straight line is there. So what is the answer here? We can say 1, 3 and 2, 4. That is B. And this is very, very important. Please note all these things. Stopping potential depends on frequency only, or kinetic energy depends on frequency, and the photoelectric current depends on intensity. Threshold wavelength for a metal having work function W0 is lambda. That means threshold, that is minimum wavelength. If it is threshold, we know that it is minimum. What is the threshold wavelength for the metal having work function? 2W0. What is the equation for W? You know that W means work function. W is equal to H nu or H nu 0. But we have to relate with the wavelength. So H nu 0 is equal to Hc by lambda. So Hc by lambda 0. Lambda and W is inversely proportional. So if we are increasing the wavelength, the work function will be reduced. Here it is written. What is the question here? It is work function is double. So automatically lambda is in the denominator. Lambda becomes half. No doubt at all. So the answer is lambda by 2, C. Option C. Next, we can go for the next question. It's very simple question. Already we have discussed what is photoelectric current depends on. The strength of the photoelectric current depends on, no doubt, how much photons will incident on a metal surface. That means the number of photons, we can say that intensity. So the answer is the option C. You can see the other options, we'll just read it out. Angle of incident radiation, the frequency of the incident radiation, intensity of incident radiation, that is the correct answer. And the distance between anode and cathode doesn't matter actually. Now we can go for, that is the correct option is intensity of incident radiation is very, very important also. Next, you can see the graph. 2 and one more. Yes, you can see the 2 more graphs. You can see that. This graph shows actually the variation of kinetic energy and the frequency. You have to identify which is the correct graph. Anyway, you know that it will be linearly increasing. So 3 graphs, A, C and D. It is increasing. But one more thing you have to note that if they are having minimum frequency, then only it will eject electron. So then only they will have energy, isn't it? So we can say that we can't start from 0. They have to start with minimum frequency. That is why we are starting with minimum frequency in the D option. So the answer is D. You have to be very careful. Usually the students will make the question, some mistake will be there. Okay, usually they will do it, but please correct it. Now we can say, for a given kinetic energy, which of the following has smallest de Broglie wavelength? For a given kinetic energy, which of the following has smallest de Broglie wavelength? Kinetic energy, de Broglie wavelength and kinetic energy relation, you know that lambda is equal to H divided by root of 2 me. E means kinetic energy. Ke, if we want, we can write, or you can simply write E itself. So if energy is same, it depends on only mass. It depends on H also, but H is constant. So we can say that if mass increases, what will happen to lambda? Lambda decreases. Here the answer it is asking is smallest de Broglie wavelength. Smallest de Broglie wavelength. So what will be the answer? Just a minute. It has gone up. Yes, you can see that. What is that? Here we can say electron, proton, deuteron, and alpha particle is given here, right? In these 4 particles, which one is having more mass? Sure, we can say alpha. So alpha particle is 2He4. It is equivalent to 2He4 helium nucleus. So we can say the answer is D, that is having smallest wavelength. You just have it that when mass increases, wavelength will be decreasing. Now let us move on to the next question. Yes, 2 lines A and B in the plot given below show the variation of the de Broglie wavelength lambda versus 1 by root V. You can see the graph here, lambda and 1 by root V is there. Don't get confused, children. Here 1 by root V is here, not root V. Usually the question will be there. The mistake you will do it, it is root V. If it is root V, it will be in the downside. That means decreasing. Here it is 1 by root V. So from this graph, you have to find which one is having smaller mass. Very easy. Why? Because you just take the slope. So which one is having more slope? It will be having, what is it, smaller mass. So which one is having more mass here? Sorry, more, what is it, slope? It is having B. So the answer will be B is having smaller mass. That you have to note it. Next, we can go for the next question. The graph shows the variation of stopping potential V0 versus the frequency of the incident radiation nu for two photosensitive metals A and B. Which of the two metals have higher threshold frequency? Of course, you know that when frequency increases, the energy also increases. So they should have minimum frequency. You can see in the graph, minimum frequency is, what is it, metal B and metal A. Here the question is higher threshold frequency they are asking. So we have to go for, just see that in the graph, you can say when it is going in the right side, it will have more frequency, though energy also will be more. So the answer will be, the options are also given there, A, B and A and B, and none of this. The answer is no doubt it will be, yes, metal A. Now we can go to the next question. An alpha particle and a proton are accelerated from rest by the same potential. That means V is same. Find the ratio of their de Broglie wavelength. We have to find the ratio of their wavelength. So de Broglie wavelength, we have to first of all give the equation for that. Lambda is equal to h divided by root of 2mqv. Q stands for the charge. Here, what is same? Potential is same. So V remains same. We don't want to take that. Other one, h divided by root of 2mq. H also we don't want to take. So only they are depending on the mass as well as the charge. So we will just compare it. You can see that lambda alpha is equal to 1 by q alpha, root of q alpha and m alpha, and lambda p is 1 by q root of 2 qp and mp. 2 also we can cancel. So when you are taking the ratio, you can see that lambda is inversely proportional to mass and the charge. So when you are writing lambda alpha by lambda p, you can see here root of qp mp divided by q alpha and m alpha. Then you should know what is the relation. This is very important for every concept. We know this one. That is, what is the relation between the charge of alpha particle and the charge of the proton? Q alpha is equal to 2 into Qp. That means twice the proton, the charge of the proton. And M alpha is equal to 4 times the mass of the proton. That you have to keep in your mind always. Now you can just substitute in this. Qp, you can write Qp itself. MP also, you can write MP itself. Now, Q alpha, when you are inserting it, when you are substituting, you can write 2Q alpha. When you are inserting M alpha, you can write 4 M alpha. So when you are for MP, so when you are substituting it, what will happen? MP and M, what is it? MP and QP will be cancelled. So what will be remaining there? You can see there 1 by 2 and 1 by 4. 1 by 2 and 1 by 4, we can say 1 by 8. Root of 1 by 8. So 8, the root of 8, we can take it as, what is it? 2 root 2. Why? Because 4 into 2, 4 we can take outside. So 2 into root 2. So the answer we can say 1 by 2 into root 2. Usually the question can be asked in the ratio of their de Broglie length. It's okay, no problem. Sometimes the question can be asked, what is it, asked in the reverse manner. That means what is the relation between, or what is the ratio between lambda p by alpha? That means proton and alpha. They can ask like that also. So when you're writing, you should be very careful with that answer. If the question is like that, you have to write the answer 2 root 2 by 1, or you can just write 2 root 2. So you should be very careful what is the ratio they are asking now. Now we can go for the next question. The answer, no doubt it is written, it is, what is it, 1 by 2 into root 2. Let us move for the next question. Who among the following established that electric charge is quantized? This question also we have studied in the first chapter, electric charges and fields. You can see that Millikan, Rontgen, William Crookes, J.J. Thomson. Which is the right answer? No doubt it is R.A. Millikan only. So the charge is quantized. You know that what do you mean by charge is quantized? Q is equal to plus or minus n. It's an integral multiple of fundamental charge. Fundamental means 1.6 into 10 raised to minus 90. That is also very, very important one. Next, we can go for which of the following statement is true regarding the photoelectric experiment. Regarding the experiment, which statement is true? That we will see which is the statement there. The stopping potential increases with the increase in the intensity of the incident light. It is not at all possible. Why? Because stopping potential depends only on frequency. We know that. Next option, we can just read it out. Photocurrent means photoelectric current increases with the intensity of light. That is the correct answer. That can be the answer. We will just read the other one also. All the photocurrent increases with the increase in frequency. No way. So the answer is B, the option B. Now we can go for the next one. The radiation of frequency nu is incident on a photosensitive metal. What is photosensitive metal? When light is incident, electrons will be ejected. In between, I want to say one more thing. When the light is incident on it, electrons will be ejected at that time itself. That means the time lag between incidence and the emission is 10 raised to minus 9 second. That means nano. That you just think it of what is 10 raised to minus second. That means it is an instantaneous process. It is one of the laws of photoelectric emission. What are things we are discussing also the laws of photoelectric emission. This also you have to add. This is also very important. Photoelectric emission is an instantaneous process. Now we'll go for this question. Here one photosensitive metal is there. When the frequency of the incident radiation is doubled, what is the maximum kinetic energy of the photoelectrons? We have to find it. What will happen when the frequency? Simply don't write kinetic energy is double. No. We have to see the options also. 4E, 2E, E plus HE, E minus HE. We will see how we have to do it. You know that H nu is equal to H nu 0 plus E. That means when light is incident, a part is given for work function and a part is given for kinetic energy. We will take kinetic energy. E means kinetic energy. So, if it is double means nu becomes double. So, you can write H into 2 nu is equal to H nu 0 plus E. We are not changing it. From this equation, what you are getting is equal to 2H nu minus H nu 0. Now, we can divide 2H nu into 2. That means H nu and H nu. Together we can say 2H nu. So we are getting here H nu minus H nu 0 plus H nu. We will put H nu minus H nu 0 together. What is it? You can just see from the equation. From the first equation, H nu minus H nu 0, we are getting E. So you can just substitute in that. You will get the equation E plus H nu. So when it is double, the answer will be E plus H nu. So please note it. This is also very important. The option C. Now let us move on to the next question. Light of frequency 1.9 times the threshold frequency is incident on a photosensitive material. If the frequency is half means 1 by 2, and intensity is double, the photoelectric current becomes. This question also usually the student will make the mistake. Here you can see that the option is double, quadrupled, halved, and 0. We will see what will be the answer. It is 1.9 times the threshold frequency. You just make it half. What is 1.9 divided by 2? 0.95. Isn't it? It is not equal to 1. It is below 1 frequency. If there is 1 frequency, that means 1 threshold frequency, then only the emission will take place. If intensity is double or anything is double, the photoelectric current should be there, means photoelectron should be there. That means electron should be ejected. So no ejection. So what is photoelectric current? There is no emission, no photoelectric current. So the answer is 0. Please note this one is very important one. Photoelectric current is not there. Answer D. Now we can go for the next question. An electron is moving with an initial velocity v, that is along x-axis. If it is x-axis, or you can put I cap. What is I cap? You know that. What is that? It is along the x-axis. You have studied last year also. And is in a magnetic field y-axis. Y-axis means j cap. Then it's de Broglie wavelength. So an electron is moving with an initial velocity v and it is inside a magnetic field. It will experience a force F is equal to QVB sin theta. You are studying in moving charges and magnetism. That chapter is very important. So in that chapter, you are studying the Lorentz force, magnetic Lorentz force. F is equal to QVB sin theta and Q into, what is it? V cross B. V cross B means, what is it? Here, cross product. So cross product means F will be the direction of the force will be perpendicular to the plane containing velocity and the magnetic field. That means K, it is moving along the z-axis, or it will be K. Then what is the answer here? That de Broglie wavelength, is there any change? Here, V is not changing. The direction of V is not changing. If there is any change in V, then only the de Broglie wavelength also changes. Why? Because lambda is equal to H by mv. If velocity changing, then de Broglie wavelength also changes. Here no change, so the answer is it remains constant. That is A. Now we'll go for the next question. In which of the following the emission of electron does not take place? We will see which are the options. Thermionic emission. You know that sure emission will take place. Photoelectric emission, we'll go for C, that is photoelectric emission. Light is incident, sure it will be emitted. And one more emission is there, secondary emission. Secondary emission means once the electrons are ejected from that, again it will hit the another electron and they will be, that is secondary emission we can say. So out of this we can say does not take place, its emission does not take place means it is no doubt it is X-ray emission. Now we can go for next question. Which of the following when falls on a metal will emit photoelectrons? Which of the following radiations, some radiations are given, who is having more frequency and who is having more energy, the electrons will be ejected, or we can call that electrons, we'll call it as photoelectrons. Then we can say, you can see UV radiation, infrared, radio waves, microwaves, it is given in that order. So the answer is UV radiation, that is ultraviolet radiation, the option is A. Next one we can say the wave nature of light was established by Maxwell's equations, Fraunhofer lines, Hertz experiment, Einstein's theory. But we have to find that wave nature in 3, here 4 is given, in which the wave nature of light was established. You have to find it. Here it is, options are given like this, 1 and 2. 1 and 2 means Maxwell equations and Fraunhofer. Fraunhofer is a absorption spectrum. So it won't come here. Next one, we can say second and the fourth one. No way. And the third one, that is C, option C. We will just read it, Maxwell's equation and Hertz. And the Hertz experiment is very important. Heinrich Hertz, we have to just recollect the name. Why? Because he only first observed this photoelectric experiment. After that, only Leonard and Halbach has completed the experiments. Then Einstein have given the equation also. After that, Millikan also done the experiment. So here the answer, the correct option we can say first and the third one, answer C. Now, which of the following metals is not sensitive to visible light? Sensitive means what is it? It is sensitive means when light is incident, electron should be emitted. You can see some of the materials are given, cesium, sodium, rubidium, cadmium. No doubt at all, the first 3 is sensitive. So the answer is cadmium. Why? Because the work function, we have to relate with the work function and the threshold energy. Now we can go for the next question. You can see that, yes, in a photon particle collision, the quantity that does not remain conserved. And this is also very important. In this chapter, actually the photon picture of light is given there. Photon picture of light means photon is having energy and momentum. Mass is also there. And we can say that sure, when photon incident on a surface, electrons will be emitted. But we don't know where it goes. We don't know whether it is conserved, may or may not conserved. So that is why you can see some of the particles is given. Some of the quantity is given, total energy, total momentum, number of photons, and none of this. You know that anyway in any collision, total energy and total momentum are conserved. You are studying in the last year also, isn't it? In the collision, total energy and total momentum always conserved. But the remaining, we can say that in this collision, photon particle collision, we can say the number of photons is not conserved. We are not getting a clear picture of the photon also. Now the option C. Next we'll go for the next question. We can say the wave theory of the light does not depend on, that does not explain, we can say. The wave theory of light does not explain. We'll just go through that. Polarization, diffraction, interference, all these are related to wave optics. You have studying there. And only one thing we can say, photoelectric current. And that is very important in this chapter. The question can be asked based upon this for 2 marks or 3 mark question also can be asked. 3 points are given. So we can't explain the photoelectric emission on the basis of wave theory because there is no instantaneous process we can't explain, no threshold frequency also we can explain, and does not depends on the frequency. 3 points is very, very important. So the answer we can say it is C. Next we can go for, again, the multiple choice question. We can say photons are deflected. Again, we are focusing photons. Why? Because photon, we can say that is a packets of energy, are deflected by. Photon doesn't have charge. They have, what is it? Energy, momentum, mass, everything they have, but doesn't have any charge. So it won't be deflected by electric and magnetic field or electromagnetic field also. So the answer, the photons are deflected by none of these. So the answer is D, and that is also very important. It is not protons. Usually the children will make the mistake when they are reading in hurry, they will read protons. Okay, so please read it carefully. It is photons. It does not deflect by electric and magnetic field. Next, we can go for the next question. We can say the de Broglie wavelength of a body of mass m and kinetic energy is given by the equation. So many equations are there. Here we can say mass and kinetic energy. First equation, de Broglie wavelength is lambda is equal to h by mv. We are substituting for the velocity from kinetic energy and EV. Half mv squared is equal to EV. So what is V squared? We can say 2 MeV. What is V? Root of, yes, we can just substitute that root of 2 MeV. When you are substituting it, you will get the answer here. Lambda is equal to h divided by root of 2me. Instead of EV, you can write energy or you can write EV also. Here the question asked is, it is related between mass and the kinetic energy. The correct option is C. Lambda is equal to h divided by root of 2me. Different forms of equations are there for de Broglie wavelength. Now we can go for the next question. Yes. Calculate the de Broglie wavelength associated with electron which has a kinetic energy of 5 electron volt. 5 electron volt means what is the potential? We know that EV0 is equal to kinetic energy. So if you're just cutting off E and V, what is the voltage remaining? 5 voltage. So the equation you have to study is very, very important equation. Lambda is equal to h divided by root of 2 MeV. There, h is constant, m is constant, and electron is constant. For a particular electron only, we can say these are constants. So if you are giving the values of h, m, and e, you will get the answer lambda is equal to root of 150 by V, or you can write 12.27 divided by root V angstrom unit. So you can just substitute what is V here. It is 5 voltage. Even though kinetic energy is given as 5 electron volts, stopping potential or voltage, we can say 5. So if you're, just substituting, you will get the answer 5.47, 12.27 divided by root V, you will get the answer 5.47 angstrom. That is the correct option A. Now, next one, a photoelectric cell. What is a cell? All of you know that we are getting electrical energy from the cell. Here, photoelectric cell means photo we are giving. Photo means light we are giving. We are getting electrical energy. So, in this cell, the conversion of energy is light energy into electrical energy. So, you can see that option C is the correct answer. Photoelectric, so many cells are there, photovoltaic cell and all. So, you have, anyway, light is there, the main part, and electrical energy we are getting from this cell. Something related to photocells, we can say. Which of the following shows particle nature of light? No doubt at all. Why? Because you know refraction is wave nature, interference. Refraction, we can say ray of light, isn't it? Interference, we can say polarization, we can say. Which of the following shows particle nature of the light, we can say. So what will be the answer? We can say photoelectric effect. Now we can go for the next question. De Broglie equation. So many de Broglies are there. De Broglie equation means lambda is equal to h by mv. Again, I'm telling lambda is equal to h by root of 2 mev or 2 mk. And it states what they are stating it. In the introduction part itself, we told that de Broglie is giving the dual nature, particle nature as well as the wave nature. So the answer, no doubt, the answer is dual nature. That is the first option, A. Now we can go for the next question. Protons and alpha particles have the same de Broglie wavelength. That means lambda is equal to h by mv. We will take the simple equation. First of all, we'll take the simple equation and we will see that it is opt for this question. We will go for this. Otherwise, you have to go for the next question. Next option we can say lambda is equal to h by mv. Here we can say lambda is same. So what is same for both of them? Here the answers given: energy, time period, frequency, momentum. Lambda is equal to h by mv means h is constant. So what is remaining? M into V. What is M? Mass. Mass is different for protons and alpha particle. We know that alpha is having 4 times the mass of the protons. So that is not same. And velocity is also not same. But mass into velocity, what is that? Momentum. So momentum can be constant. So the answer we can say lambda is equal to h by mv. H is constant. Momentum also remains constant. So wavelength also remains constant. So the answer is the option B. Let us move on to the next question. That is case-based, passage-based integrated question. That is the new type of questions. introduced by the CBSE. This year also we can have this type of question. In the sample questions also you can see that this type of question is there. One such questions I have taken for dual nature of radiation and matter. We will see that. And this diagram also you are familiar with. You can see that this is the diagram for the experimental verification or experimental setup for the photoelectric effect. You can see an evacuated electrode will be there, and evacuated glass tube will be there. That means nothing will be there inside. A photosensitive surface in the left side and the right side, one electrode which is connected to the positive. First we are connecting to the positive, that is why it is written A. And you can say commutator we can reverse the direction of the current, we can say that. Then a voltmeter, micrometer. What is the use of the micrometer? To get the current. So when the electron is flowing in the circuit, we can get the current from the micrometer, and the rheostat, it is connected to the cell also. This is the experimental setup, we can say. So when how you are getting the electrons actually, you can see a quartz window, one window is there. Through that window, the light is coming. You can see a sun is also there. But any light, we can say, when light is incident on the photosensitive surface, that means electrons will be ejected from there. When it is incident in that, electrons will be ejected. If it is a minimum frequency, then only it will be ejecting electrons. The electrons will be ejected from that. It will move on to the anode. And this electrode is connected to the positive. So sure, electrons will be accepting that or attracting, and the electrons will be flowing through the circuit, and you will get the current in the micrometer. What do you mean by that? Photoelectric current is observed in the micrometer. When we are increasing the intensity, what is happening? The photoelectric current also increases. That is the experimental part, we can say. When we are increasing intensity, we can say that photoelectric current also increases. You can see the question here. They are giving some data from this experiment. What is the data? Wavelength and the potential also given there. Retarding potential as well as positive potential also is there. We are dealing with the retarding potential. That means we are giving, retarding means retardation should be there. That means electron should be retarded. That means decelerated. That is why here this negative is given. Some data is there. The question is, why must negative potential? We are applying to electrode A. Electrode A, you know that they are attracting. To stop the flow of the electric current, why we are giving negative potential? We can say that if electrode A is positive, it will attract. Electrons will be attracted by this, right? So current will be there. But if potential of electrode is decreased, that means from positive it is decreased with respect to the potential of C, electrode A is negative. Then emitted photoelectrons will experience retardation, that is repulsion from this electrode, negative electrode, and they will move away from that. That potential, we will call it a stopping potential. Why it is called a stopping potential? They are stopping from the attraction of the anode, we can say, or we can say they are stopping. They are not coming to the circuit. That means photoelectric current also zero. That is why we'll call it a stopping potential. And only that electron will be able to reach the electrode A, which has sufficient kinetic energy. And then only photoelectric current will become zero. We know that. Otherwise, they will be moving back and photoelectric current is zero. When photoelectric current is zero, that potential we'll call it a stopping potential. And the next part of the question you can see, plot A. Any one of the question will be asked for 1 mark. Actually, 5 questions will be there, and each 1 mark question, and 4 questions you have to attempt. That is the instruction from the CBSE. Some changes will be there or not, we don't know. But still we can say, if it is 1 question, don't think that all the questions you have to do it and you have to get 1 mark. No, 1 question carries 1 mark. So we'll go for the next question. Plot a suitable graph to determine Planck's constant and minimum energy in SI unit. That we have already discussed, which is the graph, frequency and the stopping potential graph. It is a straight line graph. So here we have to find the frequency from the data given. Here wavelength and potential is already given. From that you can find the wavelength also. C is equal to nu lambda. So what is lambda? Or frequency, we can say C by lambda. So you can find the frequency. The frequency we have calculated here, it is 5.1, 5.4, 9.1, 10.5. All are multiplied by 10 raised to 14 and unit is hertz. We got this data. Now we can, now we can go for the graph. We can draw the graph. You can see the graph, straight line graph. Again, we got it, and we are not getting from 0. It is getting from the minimum frequency. You can see it. So it's a straight line graph. That means stopping potential depends on the frequency. From this graph, we will get the Planck's constant Already we have discussed and we got the Planck's constant also. According to Einstein's photoelectric equation, we know that kinetic energy or EV0 is equal to h nu minus nu phi 0. So nu, that means stopping potential V0 is equal to h by E nu minus phi 0 by E. When we compare with the equation of the straight line, y is equal to mx plus b, m is the slope. Slope is equal to h by E. From this, you will get h. H is equal to slope into E. E means the charge of an electron. You can see here, h we can find it using this equation. H, you are getting 6.6 into 10 raised to minus 34 joule per second. That is the equation for Planck's constant. And from the graph, you are getting other things also. What are the other things? Threshold frequency, the work function. Threshold frequency, minimum frequency, you will get it. If you are multiplying by h, you will get the work function. That is the case-based questions or paragraph-based questions. Now we can go for the assertion and reason. So some of the important points you have to think about the assertion and reason is, the first one we can say, if both assertion and reason are true, and the reason is the correct explanation of the assertion. That means 2 points will be the 2 statements they are giving. First we will calling the assertion and the second one is reason. And if both are correct and it is the explanation of the assertion, we can say option A. Second option, if both assertion and reason are true, both are true, but reason is not correct explanation of the assertion, we can go for B. And the third option, if assertion is true, but the reason is false, that can also be possible. So the option is C. And the D option is, if assertion and reason both are false, that means both are not correct, we can say the option D. And the E option, that the last option, we can say, if assertion is false, but reason is true, we can opt for E. First of all, you should thorough about this one. Then only we can go for the questions based on the assertion and reason. 4 questions will be there in the exam, board exam. We are telling about board exam. 4 questions will be. It can be from the different topics. Now we can go for 1 or 2 questions. We can discuss it. The first question, assertion is given as, there is a physical significance of matter waves. Sure, there is a physical significance. And matter waves, you know that it is a waves associated with the moving particles. Another name for matter waves, we can say de Broglie waves. And the reason, what is the reason? Both interference and diffraction occurs in it. So absolutely correct. Why? Because it is wave nature. So what is the answer? We can say the first option, both are absolutely correct. So option is A. That is assertion and the reason is correct, and reason is the correct explanation for the assertion. Then we can go for the second question. Assertion is given as, the process of photoelectric emission is different to that of thermionic emission. It's entirely different. The process of thermionic emission is, what is it? Temperature dependence. That means, sure, thermal means something related to heat. Heat means temperature. When temperature increases, energy will be increasing. So sure, it depends. But photoelectric emission does not depend on, it is independent of temperature. So we can say, what is the answer? We can go for the option A. Both are correct, and the reason is a correct. Reason is a correct option for the assertion also. We can go for the next question. Yes. Photoelectric effect demonstrate the wave nature of the light. Is it true? No way. We know that, isn't it? Then what photoelectric effect means, it is fully depends on the particle nature. And the reason, we will go for reason also. The number of photoelectron is proportional to the frequency of light. What is number of photoelectrons? What is number of photons means? What is it actually? It is intensity. So it does not depends on the frequency. Photoelectric current does not depends on the intensity. So the answer is the fourth option, that is D only. That means both are not correct, false, we can say. Now we can go for the next question. The energy and the momentum of a photon are related by P is equal to E by C. P is the momentum, E is the energy, and C is the velocity of light in vacuum. Its value is 3 into 10 raised to 8 meter per second. How you got it actually? E is equal to mc squared, the Einstein's famous equation, mass energy relation. And of course, we know that, isn't it? E is equal to mc squared. And we can equate the other equation, h nu also. If you are equating it, you will get momentum is equal to E by C, energy by C. And the reason, what is the reason there? The photon behaves like a particle. The photon means, what is the package of energy? Sure, it behaves like a particle. So the option, the assertion as well as the reason is correct. And the reason is also correct. what is it, reason for the assertion. So answer is A. Next one, we can go for the de Broglie wavelength of a molecule varies inversely as the square root of the temperature. That means we know the equation lambda is equal to h by root of 2m kt. That means lambda is proportional to 1 by root t. That means lambda is inversely proportional to the square root of the temperature. What is the reason behind it? The root mean square velocity of the molecule depends on the temperature. Absolutely correct. So the option is answer A, we can say. One more thing I want to say, children. Now, by this, we are completing it. One more thing I want to say. Actually, the last topic, Davison and Germany's experiment, is not included in this, chapter. Actually, it is there in the NCRT, but in the syllabus, it is not there. So, one question I want to tell that in Davison and German experiment actually verifies the wave nature of de Broglie relation. You should know that. Thank you. Thank you, sir. Children, please study thoroughly the theory part and all. Then only you can do any question. Again, I'm telling why, because question can be different and the form of question can be different, but you can do it if you are thorough about the concept. Okay. Anyway, thank you once again.
Yeah, thank you so much, Santa ma'am. You have presented this in a very beautiful manner. Some of our viewers just giving some comments. That presentation is very good and very confident you are, but a
Thank you, sir.
little bit fast. A little bit fast.
Okay, sir. Okay.
So in
Hmm.
future we will keep it in mind that the session must
Sure,
be
sure,
some little
sure.
bit slow so that
Why?
our
Because it
viewers
is 1 hour, we have to
get
complete
guide.
that topic.
Yes,
That is
yes,
why.
yes, yes. And, oh,
Okay,
okay,
sir.
okay. So thank you so much. It was a wonderful session, and already I have shared feedback link in the live chat box, so
Okay.
viewers can fill the feedback form and get the certificate in their email ID. So kindly put your email ID correct. If your email ID will not be correct, then it may be possible that your certificate will not be delivered into your email. So kindly put the correct email ID, and I would like to thank Madam Sanitha MM for sparing her valuable time from
Thank
her
you, sir.
busy schedule, because nowadays exams and pre-boards are going on. So being a PGT, we are very busy. Even I am also engaged in
Yes, sir.
school, but Madam has spared her valuable time. So thank you so much, ma'am, on behalf of One Mark Solution, on behalf of all the viewers, and
Thank you. Thank you very much.
definitely you are in Kerala, but you are helping the students from all over the country, students from the different part of country,
With pleasure,
and
sir.
with this motive only, this platform has been created and started, so that teachers from different parts of country can interact with the students from different part of country, and they can help the students of different part of country, those who are underprivileged, especially those who are not able to join the coaching institutes, etc. So they can give help. They can get help from this platform with the best teachers. They can understand the concept of different subject and different topics. So once again, I would like to thank one and all. Thank you, Sanita ma'am. Thank you, your principal ma'am also, who have always supporting you to be here with us. Kindly convey our regards to your principal
Sure,
ma'am.
sir. Sure.
Thank you so much. Thank you so
Thank
much,
you,
one
sir.
and all.
Thank you.
Very soon
Thank
we will be here again with the different chapters. Thank you so much.
you. Sure. Thank you, sir. Thank you. Thank you all.